Hello, good evening, everyone. Myself, Avinash, Assistant Professor, Department of Pharmaceutical Chemistry. So, today I'm going to discuss about the synthesis of Carbachol. So, I'm going to elaborate the synthesis of Carbachol in simple way to understand. Synthesis of Carbachol. Okay, so first we'll understand how can we synthesize Carbachol, and later we will see what are all the important therapeutic indications of Carbachol. Okay, so the starting material used for the synthesis of Carbachol this is called as ethylene chlorohydrin. So this ethylene chlorohydrin, I'm going to react with phosgene. Okay, so when you react with phosgene, what happens you'll see now. So when ethylene chlorohydrin reacts with phosgene, okay, so you see these two atoms here, oxygen and hydrogen. Okay, as oxygen is more electronegative, the adjacent hydrogen atom will become positive charge, because all the electrons will be migrated towards your oxygen. So here oxygen gets a partial negative charge and hydrogen will get a positive charge. Similarly, there are two chlorine atoms in phosgene. You know, halogens are very good, what you call leaving groups. They can leave the reaction very easily. Okay, so one hydrogen atom which is having positive charge reacts with one of the chlorine atom here to liberate hydrochloric acid as a byproduct. Okay, so what will you get here now? You will get CH2, Cl. Okay, I'm writing the same thing again, CH2. Next, so there is no hydrogen and one chlorine atom is combined to liberate hydrochloric acid here. So directly you can write CH2, single bond, oxygen, okay, followed by, so this CO, I am going to write in this way, C double bond O, and if you remove one chlorine, you will get another chlorine atom here because there is Cl2. So one chlorine atom has already combined with the hydrogen atom to liberate HCl. So there is another chlorine atom left over. So that chlorine I have written here. Okay, so this compound you can call it as chloroethylene chloroformate. Okay, now this compound you are going to react with ammonia. Okay, so we'll see now what happens when you react this compound with ammonia. Okay, now you compare the electronegativities between this carbon and chlorine. So you know chlorine will have more electronegativity. Electronegativity is nothing but it is the tendency of an atom or group to attract the electrons towards itself. That is called as electronegativity. Okay, now if I break the bond here between carbon and chlorine, the electrons will come out and migrate towards the chlorine atom, and chlorine gets partial negative charge, and this carbon will get a positive charge. Okay, so here also nitrogen will have one lone pair of electron. So when you compare the electronegativity of nitrogen and hydrogen, hydrogen will get least positive charge. Okay, so one of the hydrogen atom from ammonia reacts with chlorine, which is having negative charge. So once again, HCl is removed as byproduct. So what happens now? This, if you remove one hydrogen atom, you will get NH2. So this NH2 will bind with the carbon atom. Okay, why? Because already nitrogen is having lone pair of electrons, right? So these lone pair of electrons, if you donate for carbon, so there will be a new bond formation between the carbon atom as well as the nitrogen. So we can write this structure in this way: CH2, okay, Cl, next CH2, oxygen, C double bond O. Up to here, I have written the same thing. So now there is no chlorine here. Okay, so you can write this carbon, which is having positive charge, will bind with this nitrogen to form NH2, because one hydrogen atom has combined with Cl minus to form HCl as a byproduct. Okay, so this is one intermediate compound you got here. So in the last step, you are going to react this intermediate compound with trimethylamine. Okay, trimethylamine. So what is the formula for trimethylamine? NCH3 taken thrice. Okay, and here nitrogen will have one lone pair of electron. Okay, so there is another chlorine atom here. So once again, you break the bond between carbon and chlorine. As chlorine is having more electronegativity, the electrons will come out of the sigma bond and it will migrate towards the chlorine atom. Chlorine gets negative charge, carbon will get positive charge. Now, the positively charged carbon atom, okay, can be stabilized by using this nitrogen. Okay, so what happens here? You will get CH3 taken thrice nitrogen. Okay, what I mean to say is the lone pair of electrons which are present on nitrogen will be donated for this particular carbon. So this carbon will form a new bond with nitrogen. Okay, so this is a new bond formation between the nitrogen as well as the carbon. CH2, CH2, oxygen, C double bond O, NH2. So when nitrogen has donated its electrons towards this positively charged carbon, what happens to nitrogen here? Nitrogen will get a positive charge. Okay, so this structure, you can call it as Carbachol. Simple, very simple synthesis. So listen carefully once again. So the starting compound, what I have taken here is ethylene chlorohydrin. You are going to react with phosgene. Okay, so in these two atoms, oxygen and hydrogen, hydrogen will get positive charge, and this positively charged hydrogen reacts with one of the chlorine atom present in phosgene to liberate the first molecule of HCl. Okay, so you will get this compound called as chloroethylene chloroformate. Okay, you're getting the same CH2Cl, CH2, and this oxygen I'm written here, followed by COCl. If you remove one chlorine, there will be another chlorine atom here. This is Cl2. So one chlorine has been liberated in the form of HCl. So the other chlorine atom is present here. So in the next step, this intermediate compound, okay, you are going to react with ammonia. So what you are doing here, you are going to break the bond between carbon and chlorine. Okay, as chlorine is having more electronegativity, the electrons will come out from the sigma bond and migrates towards chlorine. So therefore, this carbon will get positive charge. Okay, so this positively charged carbon, okay, can be stabilized by this nitrogen, which has lone pair of electrons. So nitrogen will donate its lone pair of electrons for carbon. So there will be a new bond between, this is a new bond, which is formed between carbon as well as nitrogen. Okay, so one of the hydrogen atom in ammonia and this chlorine can be liberated in the form of HCl. This is a second molecule of hydrochloric acid. In the last step, this intermediate compound, you are going to react with trimethylamine. This is a formula for trimethylamine, NCH3 taken thrice, where nitrogen contains one lone pair of electron. So again, you are having a chlorine atom here. You know, halogens are very good leaving groups. So you can break the bond between carbon and chlorine. So the electrons will migrate towards chlorine atom and it will get negative charge. So this carbon will have positive charge. So positively charged carbon can be stabilized by using the lone pair of electrons which is present on nitrogen. So nitrogen will donate the electrons for this carbon. So there will be a new bond. See, this is a new bond formation between the carbon as well as nitrogen. But here, if you observe, nitrogen has been designated with positive charge. You can understand why nitrogen is having positive charge now. So whenever nitrogen is having positive charge, it is electron deficient. Why it is electron deficient? Because it has donated its electrons for carbon. So therefore, you got a new sigma bond formation between carbon as well as nitrogen. So this entire trimethylamine group has been added for this particular carbon, and rest of the structure is same. Again, you are getting CH2, CH2, oxygen, C double bond O, NH2. So this is called as carbachol. Okay. Now, apart from the synthesis, one has to understand, okay, what are the important uses of this particular drug? Where can we use this carbachol? The first one, carbachol can be used in the treatment of glaucoma. Second, the carbachol can also be used, okay, for the treatment of urinary retention problems. See, some persons will have this urinary retention problems. What happens if urine is retained for a long period of time? So it may lead to abdominal pain. And there is one important muscle which is present in the urinary bladder, and that muscle is called as detrusor muscle. So when these detrusor muscles are relaxed, what happens? The urine passage will not be so easy. So urine will be retained inside the bladder. So if the patient wants to pass out the urine, okay, if you administer this drug called as carbachol, carbachol is responsible for excessive contractions of detrusor muscle. So excess contractions of detrusor muscle will lead to passage of urine. Okay, and this process we can call it as micturition. So micturition is a process where urine is expelled out from the urinary bladder. So this is what carbachol can do. So carbachol can be used in the treatment of glaucoma, and it is very helpful in the treatment of urinary retention problems by contracting the detrusor muscles in the urinary bladder. Therefore, urine can be expelled out from the bladder and the patient can be relieved from the symptoms of urinary retention. Okay, so this is about your synthesis of carbachol and important therapeutic indications of this drug. Okay. In my next video, I'm going to discuss another important drug synthesis and very specific uses. Okay. Thank you.